Hello everyone. In this video we're going to be evaluating a radical expression. Actually, not evaluating, but more like denesting. So this is a nested square root and we're going to get rid of one of the radicals. I'll be presenting two methods. The first method, bear with me, is a little painful, but I think it's going to be helpful. So here's what I'm going to do. I'm going to set this number equal to x and find the minimal polynomial that contains this as a root. You'll see how that goes. First step, I'm going to square both sides. And then isolate the radical. And then square both sides again. So our goal is to clear all the radicals and come up with a polynomial equation. And this polynomial equation is going to have our original number as a root. So this is 9 minus 6x squared plus x to the fourth equals 5. Rearrange the terms, and you're going to get a quartic equation. But it's biquadratic, which is kind of nice. Now, obviously, you can solve this equation by setting x squared equal to something, and then turning it into a quadratic, solving it, and then going back and back substituting to find all the x values. But I'm going to use something different. Because if you do that, like if you use the first idea, you're going to get something like 3 plus minus root 5. And then when you square root it, you're going to go back to square 1. We don't want that. I want to get something different from the original expression. So let's go ahead and write this as a difference of two squares. Notice that we have these perfect squares. So x to the fourth minus 4x squared plus 4 is a perfect square, isn't it? And then just subtract 2x squared from it to get the negative 6. And now we can write this as x squared minus 2 squared minus root 2x squared. It's not as nice as it should be. Root 2 is irrational, but that's okay. That works for our purposes. And then we can go ahead and factor this using difference of two squares. And then write this in standard form. And then you'll get two quadratics. And now we're going to solve these quadratic equations, set the product equal to 0, and solve each one separately. So each equation has two solutions. Let's go ahead and find each one. So x can be written as negative b plus minus the square root of b squared, which is 2, minus 4ac, that's going to turn into an 8. So let's do one of them, and then everything else will be the same pretty much. Negative 2 plus minus root 10 over 2. Okay, and the other equation similarly is going to have positive root 2 because negative b is going to be positive root 2 plus minus root 10 over 2. So we got four solutions. Great. And guess what? Our original expression is x, remember? So since x is equal to this and we're trying to denest this, one of the roots should be the answer. But which one? That is the million-dollar question. So let's go ahead and answer that question right now. How do we know which one is which? Well, you might kind of guess because our radical, since 3 is greater than root 5, this is going to be a real number, and obviously this is going to be positive. So we can eliminate the negative solutions. For example, negative 2 minus root 10 over 2, eliminate it. And negative 2 plus root 10 over 2 is a candidate. So we're going to check it out. And now from the other equation, root 2 minus root 10 over 2 is negative, cancel it, and root 2 plus root 10 over 2 is positive, so that's a candidate. So we have two candidates. We have to pick which one is which. And you might probably guess by looking at the sign, the second one has the plus sign, but the first one has the minus sign, so that should be the answer, right? But don't just go by that. I mean, start with the minus sign and then square it. Because if you're claiming, basically this is what I'm trying to check. Is the square root of 3 minus root 5 equal to this number? How can you check that? Both sides are positive, so let's go ahead and square both sides. Or just square this and let's see what happens. Something interesting is going to happen. This is like a minus b, so root 10 squared plus root 2 squared minus 2ab. That's going to be that, divided by 4. And now let's simplify this. 12 And root 20 is 2 root 5 multiplied by another 2. That's going to be minus 4 root 5 divided by 4, and that's going to be 3 minus root 5. And guess what? If you square this, you're going to get the same thing. Therefore, this is the answer. Make sense? To keep a long story short, square root of 3 minus root 5 is equal to root 10 minus root 2 over 2. I know it's kind of hard to believe, where does the root 10 come from? But if you square both sides, again, we just did, you'll see that it actually works. So that will be the answer. What about the other ones? The others are extraneous solutions. They're not equal to the original x, but they are part of the equation. That's what happens when you square both sides, especially when you do it twice. You're going to introduce more extraneous solutions. Make sense? So far, so good? All right. If you're ready, let's go ahead and take a look at the second method, because the first method was very painful, so we do need to take a break and do something easier. But I wanted to show you this because it's kind of interesting. You can look at the roots of a polynomial and kind of match up with the right one. I think it's an important skill. Anyways, so the original problem is asking us to denest this, and there's a really cool way. Of course, if the numbers are good, and the numbers are good here, as you know, here's what we're going to do. When you are denesting an expression, it's important to get something like a plus b plus minus the 2 times the square root of ab. Why? Because the expression inside the radical is basically square root of a plus minus b squared, and the square root and the square cancel out. Okay, if that doesn't make sense to you, let's go ahead and do it numerically. So now I'm going to go ahead and multiply this. So first of all, I'm going to write it like this: square root of 3 minus root 5 over 1, and then I'm going to multiply the top and the bottom by 2. Okay, that's going to give me the square root of 6 minus 2 root 5 divided by 2. And as you know, I can go ahead and split it up into 2 radicals. Okay, great. So don't worry about the denominator. We'll take care of that later. And let's focus on the numerator. How do you simplify or denest something like this? Easy. Just with the formula that I just talked about, we can basically write it as follows. Take a look. 6 can be broken down into 5 plus 1. And this is square root of 5 plus 1 squared. Think about it for a minute. A plus b squared, a squared plus b squared minus 2ab. Uh-oh, did I say plus? It's supposed to be a minus sign. But it's under the radical. Therefore, when you take it out, it's going to be root 5 minus 1. But that's just the tip of, no, not the tip of the iceberg. It's just the numerator. So square root of 3 minus root 5 equals the square root of 6 minus 2 root 5 divided by root 2. But the square root of 6 minus 2 root 5 is root 5 minus 1. So that's divided by root 2. Rationalize the denominator, and the magic, or the mathemagic, happens. And you get root 10 minus root 2 divided by 2 as before as the answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.